Hello friends, today we are going to start with the new model number 3, that is junction, transistor and field effect devices. So let us start with the what is meant by the transistor, and we'll see the details regarding the transistor, how it is formed and other phenomena of its working principle. Okay. Now if we look at the word transistor, okay, transistor is nothing but the transfer register. What is it? It is nothing but the transfer register. Okay, so this register is, okay, it is a kind of the three terminal devices, and whose resistance between the two terminals is controlled by the uh, third one. Okay, now as we know that it is a kind of the bipolar device, okay, or bipolar transistor. And what is it? It is the one of the most important semiconducting material so far. Okay, and it was invented long back, right? And it is now part of the almost every communication system, and the what we can say, the technology as well, right? Now if we look at the its operation modes of this bipolar transistor, right? So how it is operated, right? So as we have quite a little bit yeah, information about the transistor, that the transistor can be operated in the at the three different or four different modes. That is a normal, now we call it as active mode, right? But as we can have the three junctions sorry, two junctions are there, and which are they? Something like, okay, and this is something like a emitter, then the base and the collector is there, right? So here we can have the, this is the one junction, is the second junction. So two junctions are formed here, that's why we call it as a bipolar transistor. Okay, because two poles are there. So now what we can have, so two junctions are here. So now this is three terminal devices, so one is here, one is here, and one is here, right? So what we call it as this is emitter junction, emitter, this is a base, and this is a collector one. Now if we want to have the biasing of this transistor, we can bias this using the two different board, that is we can apply the voltages to the emitter to base, as well as the collector to the base biasing modes of the operation, right? Now if we want to have the transistor be in the normal active mode, then what we can have, the eb junction, emitter base junction should be the forward bias, f for the forward bias, and the cb junction is something like we call it as collector base junction, it has to be the reverse bias. So now if suppose we consider the n p and transistor, so if this eb junction has to be the forward bias, means the negative supply is connected to the n junction, and the positive supply is connected to the base one. On the other hand, the cb junction has to be the reverse bias. In that case, what we can have here is the cb junction has to be the reverse bias, means the negative terminal is connected to the positive biasing, and the positive terminal is, or base is connected to the negative one, positive, or the p type terminal is connected to the negative biasing, so it becomes a reverse bias. So this is the condition for, to have the its mode of operation to be normal and the active one. So the eb junction has to be forward bias, and cb junction has to be the reverse bias. If you want to have the higher amount of the current to be flown through this transistor, it should conduct very highly, then the it should go into the saturation. Okay, saturation, it should conduct very highly. So how we can get such a mode of operation? When the eb junction is forward bias, and the what we can have, the cb junction has to be the reverse bias. Okay, now the both the junction has to be the forward bias, we can get the saturation one. If suppose the both the junctions are in the reverse bias, then the transistor will be in the cutoff range. Okay, in the cutoff junction. If now the if we just reverses the normal active mode, the biasing condition, then we will get the inverse operation mode of the transistor. That is, EB junction has to be the reverse bias and CB junction has to be the forward bias. So this is something like the operation modes of the bipolar transistor. Okay, now let's move ahead little bit and we'll talk about the some static characteristics of the transistors. Okay, now yeah, if we just look at the its static means there is no changes happening over the period of the time. It's the DC biasing conditions under that we are trying to see its characteristics. So first thing is that the basic IV characteristic, basic uh, the current voltage relationships. Okay, how are its characteristics we are going to see over here. If you just try to understand the symbols of this uh, transistor, that is it is already well known for the most of us, that is the EB, that is the NPN transistor and PNP transistor. There are two different types of the transistor there. Okay, that depends upon the separation between the two types of the regions with the another kind of the region. Okay, so the polarity is the different okay at the sandwich layer. Okay, now here what we can have, if in case of the uh, there are three terminals. Okay, so the emitter, base and the collector. Generally the emitter is heavily doped, base is lightly doped, and its area is very small. Okay, width is very small, and the collector is every time is a little bit lightly doped as compared to the emitter one, and it can have the area is wider one, so that it can collect the most of the charges which are pass through the base. Okay, so it should collect, that's why its area is mostly um, larger as compared to the emitter one, and emitter is heavily doped, so that we can have the large number of the uh, mm, charges can be emitted by the emitter. Now here we can have the the type of the transistor is the NPN, right? So here the arrow indicates the that is the current flow direction, current flow direction. So the current flowing through the collector is represented with the IC, through the current through the base is represented with the IB, and the current through the emitter is represented with the IE. Now if we just try to reverse the polarity, then the type will get changed, and obviously the current direction will get reversed as well, right, in case of the PNP transistor. So the P plus or the N plus indicates that it is heavily doped. Okay, or the majority there are more number of the charges are mm, doped inside it. Okay, now if we and here, yeah, if you try to look at the its symbolic representation of the transistor, then we can have this representation, and the arrow indicates the current direction towards the emitter, current direction towards the emitter. Okay, so the this arrow indicates that where is the emitter one. Okay, or else the, if you just try to look at the three terminal device on the transistor, on the if it is like this, okay, three legs are there. So the where which side the notch is there, that is near to the emitter one. Okay, so in real practice, this is how we have to understand the where is the emitter one, the base is near, and then the collector we can understand easily. Okay, now the next thing is that the in case of the PNP transistor, the direction of the current is the reverse one. Okay, is the opposite to the one. Now these transistors can be connected in the three different configurations. Okay, now and this even is modes of operation already we have seen in the earlier this diagram as well, right? So now this transistors can be connected in the three different configurations, and that is nothing but the it is represented in this diagram. Okay, you can see it very clearly. That is nothing but the common base, common collector, and the common common collector and the common emitter configurations. Okay, uh, for the NPN transistor we have shown here, because this arrow indicates that whether it is NPN or the p and p1. Okay, so the and these are the all things are given for the what we can say the normal modes of its operations. Okay, all signs and polarity should be inverted in case of the PNP transistor. So let us will in the whatever the discussions will have, will consider the NPN transistors, and the results are applicable to the what we can say to the PNP transistors with an appropriate change of the polarity and its physical parameters. Now here we can see the common base means the base is common and the input is applied at this what we can say the VBE. Okay, VBE is the polarity is here, and the what we can say here it is something like uh, here VCE. Okay, VCE is here applied here, so the base is common for the both. Here the emitter is common. Okay, and in this case the collector is common. So these are the three different configuration of the transistor biasing in case of the normal mode. Now the latter things about the how it is getting operated, and its working principles or the biasing conditions will see in the succeeding lecture.